When installing Type NMC cables in crawl spaces, it is important to adhere to the National Electrical Code or NEC guidelines for safer and compliant installations. Regarding cable routing, there are two primary methods: stapling and drilling. When stapling Type NMC cables, they can be stapled under floor joists. However, a critical detail is that if the cables are stapled within 6 inches from the edge of the joist, they must be protected. This protection is typically achieved using a nail plate or other approved means designed to shield the cable from physical damage. If the cables are stapled further than 6 inches from the edge of the floor joist, no additional protection is required. Alternatively, cables can be routed by drilling through the floor joists. This method eliminates the need for stapling and, if done correctly, provides inherent protection to the cables. When drilling, ensure that the holes are properly sized to avoid damaging the cable during installation or causing stress points. Concerning protection requirements, the NEC mandates specific measures based on the cable's proximity to the joist edge. If cables are stapled under the floor joist within that critical 6-inch zone of the edge, they must be protected by a nail protector or another approved means. This is to prevent nails, screws, or other fasteners from penetrating the cable, which could lead to electrical shorts or fire hazards. In contrast, if cables are stapled under the floor joist at a distance greater than 6 inches from the edge, no specific protection is mandated by the NEC. This is because the likelihood of accidental damage is considered to be lower in this scenario. In addition to these specific rules, several additional notes should be considered when installing NMC cables in crawl spaces. Firstly, cables should be secured at intervals not exceeding 4.5 feet. This ensures that the cables are properly supported and prevents them from sagging or becoming damaged over time. Secondly, cables should not be exposed to excessive moisture or dampness. Crawl spaces are often prone to moisture, so it is important to take steps to mitigate this risk. This may involve using moisture-resistant cables or implementing vapor barriers. Thirdly, if the crawl space is used for storage or access, the cables should be protected from physical damage. This is particularly important in areas where there is a risk of items being dropped or dragged across the cables. Protection methods may include running the cables through conduit or using cable trays. To summarize, when installing Type NMC cables in crawl spaces, firstly, you can staple the cables under the floor joists, but if stapling within 6 inches of the joist edge, protection is required. Secondly, drilling through the joists is another viable option. Thirdly, always secure cables every 4.5 feet. And fourthly, protect against moisture and physical damage, especially in storage or access areas. Adhering to these guidelines will ensure a safe and compliant electrical installation. Understanding the NEC requirements for installing Type NMC cables in crawl spaces is crucial for electrical safety. The code specifies rules for cable routing, protection, and support to prevent electrical hazards. When installing NMC cables, you have two main options for routing: firstly, stapling them under floor joists, or secondly, drilling them through the joists. If you choose to staple the cables, be aware of the 6-inch rule. If the cables are within 6 inches of the joist edge, you must protect them with nail plates or other approved methods. However, if the cables are more than 6 inches from the edge, no additional protection is needed. Alternatively, drilling through the joists can provide inherent protection to the cables. Regardless of the routing method, it's essential to secure the cables at intervals not exceeding 4.5 feet to prevent sagging and potential damage. In crawl spaces, moisture can be a concern, so consider using moisture-resistant cables or implementing vapor barriers. If the crawl space is used for storage or access, take extra precautions to protect the cables from physical damage. This might involve using conduit or cable trays to shield them from impacts. By following these guidelines, you can ensure a safe and compliant electrical installation in crawl spaces. Proper installation not only protects against electrical hazards but also ensures the longevity and reliability of the wiring system. Always refer to the latest edition of the NEC for the most up-to-date requirements and consult with a qualified electrician if you have any doubts. Let's dive deeper into the specifics of NMC cable installation in crawl spaces to ensure we cover all the necessary details for a safe and compliant setup. Firstly, let's address cable routing options. You have two primary methods for running NMC cables in a crawl space: stapling and drilling. When stapling, it's crucial to understand the 6-inch rule. If you're stapling the cable within 6 inches of the edge of a floor joist, the NEC mandates that you protect the cable from potential physical damage. This protection typically comes in the form of a nail plate, which is a metal plate installed over the cable to prevent nails or screws from penetrating it. The nail plate should be securely fastened to the joist and cover the cable adequately. If you're stapling the cable more than 6 inches away from the joist edge, you're generally not required to provide additional protection. However, it's still a good practice to ensure the cable is securely fastened and not subject to undue stress or abrasion. Drilling through the joists is another acceptable method for routing NMC cables. When drilling, make sure to use the appropriate size drill bit to avoid damaging the cable. The hole should be large enough to accommodate the cable without squeezing it, but not so large that the cable can move excessively. It's also important to avoid drilling through structural members of the joist, as this could weaken the joist and compromise its integrity. Next, let's discuss cable support. Regardless of whether you choose to staple or drill, the NEC requires that cables be supported at intervals not exceeding 4.5 feet. This means that you need to secure the cable to the joist or other structural members at least every 4.5 feet. This support prevents the cable from sagging, which can put stress on the conductors and lead to premature failure. When stapling, use appropriate cable staples that are designed for use with NMC cables. These staples should be driven in straight and not too tightly, as this can damage the cable insulation. When drilling, you can use cable ties or other approved methods to secure the cable to the joists. Now let's turn our attention to environmental considerations. Crawl spaces are often damp and prone to moisture, so it's important to take steps to protect the cables from moisture damage. This can be accomplished by using moisture-resistant NMC cables, which have a special outer jacket that is designed to resist moisture penetration. You can also install a vapor barrier to reduce the amount of moisture that enters the crawl space. Additionally, be aware of the potential for physical damage in the crawl space. If the crawl space is used for storage or access, the cables are more likely to be damaged by objects being moved around. In these situations, it's a good idea to protect the cables by running them through conduit or using cable trays. Conduit provides a physical barrier that protects the cables from impacts and abrasion. Cable trays are open-top supports that allow you to run multiple cables in a neat and organized manner. Finally, always remember to follow all applicable electrical codes and regulations. The NEC is a comprehensive set of rules that are designed to ensure the safe installation of electrical wiring. It's important to be familiar with the NEC requirements for NMC cable installation in crawl spaces and to follow them carefully. If you're not comfortable working with electrical wiring, it's always best to hire a qualified electrician to do the work for you. In summary, installing NMC cables in crawl spaces requires careful attention to detail and adherence to the NEC. By following the guidelines outlined above, you can ensure a safe and compliant installation that will provide years of reliable service. We will now look at the materials required to perform this job properly. Firstly, you will need the appropriate length of type NMC cable for the circuit you are installing. Be sure to select a cable size that is appropriate for the amperage of the circuit and the distance it will be run. Consult the NEC for guidance on cable sizing. Secondly, you will need cable staples or cable ties for securing the cable to the joists. Select staples or ties that are designed for use with NMC cables. Thirdly, if you are stapling the cable within 6 inches of the joist edge, you will need nail plates to protect the cable from physical damage. Fourthly, if you are drilling through the joists, you will need a drill and drill bits of the appropriate size. Fifthly, you may need conduit or cable trays to protect the cables from physical damage in certain situations. Sixthly, you may need a vapor barrier to reduce the amount of moisture that enters the crawl space. Seventhly, you will need basic hand tools such as a screwdriver, pliers, and wire strippers. Eighthly, you will need safety glasses and gloves to protect yourself from injury. Ninthly, it is a good idea to have a voltage tester to verify that the circuit is to energize before you begin working on it. 10thly, refer to the relevant tables in the NEC for specifics like 334.15, which talks about securing and supporting non-metallic sheath cable. Understanding the NEC tables relevant to cable installations is critical for compliance and safety. Let's highlight some key NEC tables and sections related to NMC cable installations. NEC Table 310.15b16 provides ampacity ratings for conductors. This table is essential for determining the appropriate size of NMC cable for a given circuit based on the amperage it will carry. The ampacity of a conductor is the maximum current, in amperes, that it can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Section 334 covers the requirements for non-metallic sheath cable, types NM, NMC, and NMS. This section provides detailed information on the uses permitted and not permitted, installation requirements, and ampacity of NMC cables. It's crucial to review the section thoroughly before installing NMC cables. NEC Section 300.4 addresses protection against physical damage. This section requires that cables and raceways be protected from physical damage where subject to it. In crawl spaces, this often means protecting cables from nails, screws, and other objects that could penetrate the cable. NEC Section 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. This section provides requirements for the installation of boxes and fittings used with NMC cables. It includes information on box fill calculations which determine the number of conductors that can be installed in a box. NEC Table 314.16 provides the maximum number of conductors allowed in standard boxes. This table is used to ensure that boxes are not overfilled, which can lead to overheating and other problems. NEC Section 250 covers grounding and bonding. This section provides requirements for grounding and bonding electrical systems to ensure safety. Grounding and bonding help to prevent electrical shock and fire hazards. NEC Section 320 covers armored cable, type AC, metal-clad cable, type MC, and cable trays. While these wiring methods are not NMC cables, they may be used in conjunction with NMC cables in some installations. It's important to understand the requirements for these wiring methods as well. NEC Article 100 provides definitions for terms used in the NEC. This article is essential for understanding the meaning of various terms used in the code. It's a good idea to review this article before starting any electrical work. When using these tables and sections, it's important to refer to the latest edition of the NEC, as requirements can change from one edition to the next. It's also a good idea to consult with a qualified electrician if you have any questions or concerns about the NEC requirements. In addition to the NEC tables and sections mentioned above, there are several other resources that can be helpful for installing NMC cables. These resources include, firstly, manufacturer's instructions. Always follow the manufacturer's instructions when installing NMC cables and related equipment. The manufacturer's instructions will provide specific information on the proper installation methods and safety precautions. Secondly, training courses. Consider taking a training course on electrical wiring. These courses can provide you with the knowledge and skills you need to safely and effectively install NMC cables. Thirdly, online resources. There are many online resources available that can provide you with information on NMC cable installation. These resources include websites, forums, and videos. However, be sure to verify the accuracy of any information you find online before relying on it. Fourthly, local electrical inspectors. Your local electrical inspector can be a valuable resource for answering questions and providing guidance on NMC cable installation. It's a good idea to contact your local electrical inspector before starting any electrical work. In addition to these resources, it's important to use common sense and good judgment when installing NMC cables. Always take your time and be careful. If you're not sure about something, ask for help. And never take shortcuts or compromise safety. By following these guidelines, you can ensure a safe and compliant NMC cable installation.